The second exercise out of this section addresses the second type of variation that we encounter, and that's direct variation involving powers. Here I'll refer you to definition 7.7. We say that y varies directly with the nth power of x, or in other wording, y is directly proportional to the nth power of x, if we have the following. If y equals k times x to the n. Now this introduces a second an additional quantity that we haven't seen in the previous problem. Now the way that we know that this is the case in which we find ourselves is by reading the question. We're told that the distance that a body falls varies directly with the square of the time of the fall. So here we have the direct variation, this time involving the square. So we could say that n equals 2. We're talking about the second power. Now the variables in question, we have the distance varying with the time of the fall. That means that the distance would be our y, our dependent variable, and the fall, or the time of the fall, how long it takes for the body to fall, would be our independent variable. So as a body falls for more time, the distance that that body falls is going to change. Now, we also know in this case that if a cliff diver falls 66 feet in 2 seconds, we are saying that y is 66, and the time of the fall, x, is 2. So we have a lot of pieces here. Now if we put these pieces all together, we'll see something a little bit more interesting. So if we have 66 equal to k, which we are not told, times x, we know x is 2, clean that up a little bit, 2, and the power in this case is the second. Y varies directly with the square of x. So, where does that leave us? Well, we know that 66 is equal to 4k. If we divide both sides of this equation by 4, then we'll see that k is equal to 66 fourths. Now you could leave it like that, or you could round your answer. I like to leave it in that fraction form. Now, why this matters to us is we are curious about that last part. We want to know how far will the diver fall if we change the length of time that the body is falling for. So in this case, we'll make a little room here. Our model, we know, is y equals 66 over 4 times x squared. That squaring doesn't change. That's always going to be the case in this body falling type of situation. But we're changing something. We're changing the length of time that the body is falling. So if x now is not 2 seconds, but is instead 2.25 seconds, how does that change y? How far will the body fall in that time frame? So if we plug in this different value for x, we'll get 66 over 4 times 2.25 squared. And that works out to about 83.5. Now, in all of these problems, we have units associated with the quantities in question. So 83.5 is the number, but in words, we want to say the body, or the diver, falls 83 3.5 feet in that time frame, in 2.25 seconds. Okay, so that was the direct variation involving powers. The next type of variation that we'll see is inverse variation.